Introduce myself. I'm Bridie McGreevy. I'm a faculty member in communication and journalism, and it's my pleasure to introduce Dr. Karin Limburg, who is a professor of fisheries and ecosystem sciences in the College of Environmental Science and Forestry at State University of New York, otherwise known as SUNY ESF. In most seminars on campus, you probably wouldn't expect to find a communication researcher introducing a fisheries scientist. But these are the kinds of alliances that you do find here in the Mitchell Center. For us, interdisciplinarity is where it's at, because we see it as essential for addressing some of the most vexing and complex problems that we currently face, such as the one that is the focus of Karin's presentation today at this intersection of population, consumption, and natural resource use. So it was in this interdisciplinary space that I was first introduced to Karin's work, as she's also taking a systems approach to dams in her work on the Mohawk and the Hudson River that is similar to our focus on the Future of Dams project, and many of the people here are involved in the Future of Dams. Her research spans many kinds of boundaries, including boundaries in the sciences, blending ecosystem theory with fisheries, population, and community theory, boundaries in salinities, studying both marine and freshwater systems, and also boundaries in geography with studies from Lake Erie to the Baltic Sea. In keeping with this interdisciplinary approach that's really characteristic of her work, she's also looked at how economic drivers enable sprawl development and how this in turn affects watershed function and river integrity. And then more recently with John Waldman, she wrote a forward-looking piece advocating that when dams are removed, renewable energy capacity can be maintained within the system with solar and wind development in the drained reservoir. And this piece got a fair amount of buzz in the press.
A lot of trolling.
Yeah. That's when you know you're onto something. I met Karin the first time earlier this year when I was visiting SUNY ESF to give a talk about sustainability science. And the new documentary about Rachel Carson had just aired on PBS. If you haven't seen it, highly recommend it. It's a really good piece. And we made an immediate connection because Carson has influenced both of our careers as a figure. But in a funny coincidence, I was also giving a lecture about Rachel Carson this morning, and I was describing her courage as a scientist to say the things that weren't always popular, but needed to be said, that were really necessary. And in Karin's writing and in her talk today, she shows a similar courage and commitment, taking what may be an unconventional stance, but one that looks to the future to envision how could this be different? How do we think differently about what's possible here? So we're really interested in hearing your perspective about this complex issue of population and having a rich discussion in follow-up to this talk. I also want to make a plug. We are going to have a smaller group discussion, and you're welcome to join us at 4 o'clock as well if we run out of time in the Q&A. So thank you for being here.
Thank you. Yeah, I was just reminiscing too much down memory lane here, but this talk grew out of some discussions and a course that I taught, getting interested in issues of revisiting issues that were very hotly debated or very important when I was in my college years, and then sort of disappeared. And it seems like it might be time for us to have a view of it again. I gave this particular talk at the centennial meeting of the Ecological Society of America. We had a session on population growth and its impacts. So they asked me at that one to sort of focus it on fisheries. So that's why it's a fisheries perspective. Bob Hughes is a past president of the American Fisheries Society, also very interested in all of these kinds of issues. And the third rail I just put here because it seems like population seems to be a third rail kind of an issue. You put your hand on it, you might get a very bad spark. So that's why that's sort of by way of introducing this. So this I just took this little measurement. I took a reading on a couple of days ago. I think world population is estimated to increase another 500,000 by this afternoon. I just checked it. So there are these population clocks out there that you can look at, and I happen to like this one, Worldometers. It has a lot of different kinds of information you can look at. And when I looked at it before the ESA talk, we had about, I think about 200 million people fewer on Earth. Actually, the rate of growth of the human population is slowing, but we still got 500,000 people between Saturday and today, so it's still quite a lot of people. You look at these things, some of the kinds of stats that you can find on some of these clocks will show you the history of human population growth, and it probably comes as no surprise that we are in an exponential growth phase, expected to tail off at some point in the 22nd century, I guess. And currently this clock projects that we'll hit about 11.2 billion people by 2100. It will change as more data come in, of course, and the projections keep changing. But one of the sort of interesting things is what people used to think was the capacity of the Earth for people. So what do you guys think? What do you think people thought, like maybe, let's say 50 years ago? How many people could the Earth support?
Between 500,000 and infinite.
Wow, well, there you go. Any thoughts there? How about if we take this back to 1949? Maybe it's 39, forget. What do you think we thought?
5 billion?
Pardon?
5 billion?
5 million?
Billion.
Billion. Ah, well, yeah, it seems real. Any other takers here?
1 billion.
1 billion, do I hear half billion? Well, ecology, Principles of Animal Ecology published this graph in 1949 and projected with the data that existed a pretty good fit at 2.6 billion. Obviously, the way you fit the data is this was probably fit by eye back then, but at any rate, this is, we've really exceeded that, and right now we're more than we're about 3 times that right now. So so humans are here, and we have an impact, as you know. Some of this impact can be expressed in a way that this scientist Paul Ehrlich described. Paul had the insight that it wasn't just numbers of mouths or people. It is what is their impact is actually a function of how they extract the resources. The relative affluence, so richer people can extract more because they can afford more technology, and so on. So he came up with this relationship, which was debated in the 70s. And Ehrlich, you guys who are college students now, you probably have no clue who this guy is. Well, he was a butterfly ecologist, turned into a population, a person who advocated for reducing the world's human population because he saw the direction that it was going in terms of biodiversity threats and habitat loss and so on. But he was an amazing influence. He and his wife put themselves out in the public eye and were very controversial people, actually. They're retired now, but still I think they feel the same way. So this equation here is called the IPAT equation. And people have debated in the literature whether you can actually demonstrate it and so on, but I think you actually can. And so for the ESA talk, I actually put together some data from World Bank and various sources and tried to see how it would look. And so the impact you can express as something like an output like this. Carbon dioxide emissions is an impact, and we know very well how we can describe the effects of that impact on global warming, and I could spend a whole other lecture on that for you. But if we look at some of the potential drivers of that, population certainly has a log trend with that. GDP has a tighter trend. And then I even tried to use cement consumed per country. I found some statistics on that also line up in a log way with this. And I think this could possibly be a proxy for technology. There may be others that might be better, like, I don't know, the bits calculated per second or something like that. I don't know. But anyway, so you can see these, and then when you combine these together, you do have a very strong relationship too. So I think IPAT is essentially a real phenomenon. So then, of course, this is about fisheries, the impact on fishery resources, and I always kind of go back to my touchstone of American shad. and looking at what was a baseline, historical baseline of great abundance, and the heart of kind of the bullseye, I think, of American shad abundance was probably the Chesapeake Bay region and the Susquehanna, which has very few shad today, but had huge runs and huge harvests of shad. And John Waldman, who some of you may have read some of his work, was able to find documentation that people would go out and watch for the shad run in Susquehanna River, and they would actually see the river bulge. They could see the run come in, and the Susquehanna is a big river, and they would see the bulge moving up, and they'd call shadow, and the shad would come, one of the things that we know is that there's biodiversity impacts of population growth and consumption, and it's hard to get those kinds of data across the globe, but we were able to pull some of this information together. I have to give credit to Brian Check for starting this data set. But if you look at GDP per capita, so that's adjusted for the consumer price index, so you're adjusting for inflation over time or population, both of them are very closely correlated. And you look at the total threatened and endangered species of the aquatic portion of that, both of those trend up linearly with both indexes of growing population and wealth consumption. So, and these are not static, it's not a cumulative graph because in theory at least species come on and off the list. So it's not completely just a cumulative list. So that's one thing that we can see. If you look at, this is another big collection of global data. I call it the Sophia report. I think a lot of people do. It used to be the state of state of fisheries and inland aquaculture. That's why it was called Sophia, but now they changed the name of it. But every 2 years, this report comes out. So the last one came out in 2016. But I've been interested in following it ever since I read a paper by Botsford et al. In the 90s that showed that pulling data out of this can be informative about overfishing. But they have a lot of good global statistics. And one of the things I always show my fisheries class every year is the latest graph from this table. And this is world captured fisheries and aquaculture production. And as you can see, the portion of global fish biomass produced and consumed is increasingly aquaculture. And what you also see is that since the mid-90s, capture production, as they call it, has been somewhat level, slightly declining, and this has been growing by leaps and bounds, the aquaculture portion. And so it looks like maybe we hit, just like we talk about peak oil production, peak fish was probably somewhere in the mid-90s, something like that. Now, I don't think they're going to be able to pull out much more than that, but time will tell. Another thing that you can look at in those statistics is you can look at, they separate out by percentage in these wild capture fisheries, how much has been fully exploited, how much is not fully exploited, and what's depleted or closed or recovering. So depleted, closed, and recovering means that they collapsed the fishery. So if you look at that, the inverse of that, 100 minus that, is what's not overexploited, what is, and some look at that as a reserve capacity. But at any rate, if you look at it up to, from when the record keeping was started up to 2006, you've got a fairly nice linear trend. And if you project that up to 100%, you see that we'll be completely exploiting by about just before 2050. And that agrees very well with a conclusion that came out in a paper, either in, I think it was in Nature, by the folks at the Fisheries Science Center at the University of British Columbia a while ago now, saying that we would collapse all the fisheries, we would overfish everything by 2048. But I think they were probably working with the same statistics. But something that was very surprising to me was when I started to look at more and more recent data was that, in fact, more recent data actually showed this sudden uptick in trend. And if you plot through that, you would say, wow, we probably are actually hitting that exploitation right now. But that was from the 2014 Sophia report, and the 2016 report added 2 more data points. So I don't know exactly what's going to happen, but we're certainly still up there very close to 90%. And that's, when people started to look at this, they were upset when we had already exceeded 2/3 of this exploitation. There's other data sets that are out there floating around. This is a data set that I found that was an index of overfishing developed by the East-West Center out in Hawaii. And so when you pair that for different countries with population sizes, you get a very kind of noisy relationship, but it's still a positive relationship that more people does seem to increase the index of overfishing, and it's a significant relationship. Another topic that I'm very engaged in these days, sorry it's under your little rubric there, is the spreading of coastal hypoxia. And it's not just coastal hypoxia anymore, it's there are widespread areas of the open ocean that are losing oxygen as well, and that's very clearly a climate change effect. The coastal hypoxia has been a problem which was first understood in a nutrient context, too many nutrients coming off of watersheds, and you get things like the dead zone occurring in the Gulf of Mexico or problems in the Baltic Sea and so on, but global warming is exacerbating that. But if you look at some of the data that existed in the 1970s, you had some hot spots up here in New England, Europe, Gulf of Mexico, Pacific Northwest, Japan, and so on. Then by the 2000s, you have more. And so a very influential paper was published in 2008, which showed the growth of hypoxia zones as we understood them, and hits up at about 400, but now we know that there are over 500 that are documented systems, and we also know that there's severe underreporting in a lot of the world, particularly around here. So if we could get the information published that is actually collected in India and the Philippines and so on, this would be a much larger number. This is too bad that we can't quite see there, but that says, think about other impacts that we're an increasingly urbanized species, we people. We are actually now at about over 4 billion people that live in urban areas. So of our 7.5 billion people, over half of us live in urban regions. This was a really interesting graphic I found at the UN Population Division, where they plotted data from 1970, 90, and 2014, and then also had a projection to 2030. Unfortunately, they've pulled this from their website now, so I can't go back and update it. But what you see here is the percentage of urban centers, or the percent urban countries, sort of mapped out as solid colors, and then you also see city populations arrayed around. And so the smaller green dots, just small cities of 1 to 5 million, and then you got medium-sized big cities that are 5 to 10, and then you have a couple of mega cities. I think there are 3 or 4 mega cities on here, New York being one of them right there. And so then if we go up to the future and look at the data from 2014, we have a lot more urbanization in general around the world, and we have a lot of mega cities too. So if you just toggle back and forth between these, it's pretty amazing to see it. And I also draw your attention to the fact that a lot of these are coastal places too. So we are also a species that uses coastal areas a lot. You might ask, what are the fisheries consequences of this? So one thing that I've worked on in my work in New York State, I guess mostly, is looking at some of the processes of urbanization and what are the consequences of that. And I found one data set that I thought was quite interesting, which for a global data set, which was a relative change of urban land cover. So somebody had taken coverage maps from 2000 and 2010 and did a change analysis of it. And so then if you add in the population data and plot that as a change as well, so the amount of change of population over a decade against the relative change in urban land cover. So you have, again, a very strong relationship, and the slope is greater than 1. And that is excluding these countries, Bahrain, the United Arab Emirates, and Qatar, that these are actually more like little city states. You know, they're very limited areas. They don't have a big footprint to expand, so they expand upward, I guess, is what they must do, because their population growth is way in excess of their land spread, their urban land spread. But you can see, I mean, a value of 2 here means that the country has doubled its urban land cover, but of course it's a relative change, so it could still be small, I guess. So when I was at a conference presenting this, I actually first presented this stuff at an ecological economics conference, and one of the people I met there said cities are the scale of sustainability. That's how we've got to live in the future. And so if we can make cities sustainable, how sustainable are they right now is kind of a question I've had. And so the things I've thought about, and from my work in the Hudson Valley and around central New York and stuff, is what happens? What are some of these ecological consequences? Well, we have, of course, the hardening of watersheds where we increase impervious surfaces, and I think you've all probably learned that in Watershed 101. There's also what I call vertical hardening, which is the increase in the number of dams, and that probably happened first. Maybe it happened in tandem. Because of these things, we've lost a lot of habitats, ecological connectivity, ecosystems in general, and we've gained some species, we've lost others. We've had a general degradation of air and water quality, and consequently, we've lost a lot of what are called ecosystem services as well. This picture should make Steve Coghlan feel right at home. This is the Onondaga Creek, where he probably spent many a happy hour fishing for sick rock bass like this. But this is just an example of what an urban stream might look like. Maybe streams never looked like that up here in Maine because it's just such a pretty place. But these are just some pictures from around my neighborhood. In fact, so here's a nice little stream. Oh no, that's the street I live near, actually. But so obviously there's a lot of surface runoff during intense storms. Washes salt, washes poop, washes everything off, right down into the gutters and so on. You never see anything like this in Maine, though, I'm sure. A study I did when I was a graduate student actually was looking at we did a study looking at spawning bionadromous fishes in some tributaries of the Hudson River estuary, and we were really interested in what we were trying to quantify was fish flux, the flux of eggs and larvae out of tributaries and contributing to the main stem. And what we actually found, to our surprise, so we were studying 16 creeks and rivers in the Hudson of different sizes, from New York up to Albany, and going out weekly for 15 weeks and collecting eggs and larvae and stuff. And one of the most profound things that came out of it was this relationship here, that when we actually looked at the percentage of the watershed and urban land uses, it was an inverse relationship. And it hadn't really been documented that much before. For one thing, GIS was still kind of in its early stages, and so the tools weren't so easy to use back then, but this was mostly alewife that was stopped. So it's kind of a phenomenological curve. We never really got the full understanding of the processes, but this has been seen again and again. This was a paper published by Li-Jun Wang in Fisheries in 2003, and saw basically the same sort of thing, looking at cold water index of biotic integrity, looking at trout, looking at other intolerant fishes, but again, seeing the same kind of inverse relationship against, in their case, connected imperviousness. That's very similar. And you can just keep on doing this. You can find one index after another. Here's a benthic index of biotic integrity showing also a negative response. So then I know this seminar has a strong interest in dams, and I do too, looking at the impacts of dams, but just even getting an appreciation of the magnitude of our activity. We are just as busy as beavers doing this stuff. And I found this very nice compilation. This is a data compilation turned into a movie. So it's the data from the National Inventory of Dams from 1800 to I think 2002 or 3. So if I just play this, I can stop on any year if you want, if you're interested in looking at a particular year. But I would suggest you look at sort of around the 30s, the 50s, and the 70s. And I think you're going to see some jumps, like boom, and then boom, and then boom. So we have a lot of dams in this country, and then the whole country disappeared, apparently. Wasn't supposed to disappear. But that is only showing what's in the registry, and it doesn't include all of the small dams, the small obstructions, the culverts, and so on that probably some of you studied. The purposes of dams, I think we could classify them as hydro being one of the important things. Of course, it's considered a green, clean energy. I think many people would disagree with that. Obviously, they have multiple purposes: water supply, flood control, navigation. Some things like this get tacked on, and these things get combined. But also, of course, dams are felt, their effects are felt, and there's some very nice work that was done out of the University of Georgia just trying to highlight some of these ecological effects that you get inundation of land, you hold back sediments, change the biogeochemistry, ecological relationships. But also, I think one of the things that you guys probably think about quite a bit is how it's changed our perception of rivers. And so we now think of them in a built landscape. So instead of thinking of an open stream like this, what we do is we commodify them. So we make them into money-making entities. And so that changes the perspective of people on their land and water. So these dams here are some of the great engineering feats of the world. People really love to build giant dams. And so with these dams comes big change, as I think you probably know. I attended a session at the American Fisheries Society that was actually an international symposium on the effects of development of large watersheds that are currently undergoing development, and that means basically outside of the first world, in the third world. And so the Mekong watershed has a tremendous amount of damming. Some of it's completed, and a lot is ongoing right now. The dams, though, so they're bringing wealth to at least some part of the population, but of course they do more than make money. And this very old slide of mine, I think that this picture of shad must be at least as old as the rest of this paper was. But this is actually kind of timely for here because it is a graph of the decline of shad in Maine as a function of damming. So they were basically extirpated from here because of dams and overfishing. And now, of course, you guys have been kind of on the leading forefront of opening up those rivers again. So you've kind of been through it and coming out the other side. But it has taken a big hit. We've learned a lot from Maine and from other places, and yet we're doing it again in other parts of the world. So this paper here came out last year looking at 3 large basins, the Amazon, the Congo, and the Mekong. And just it was a very nice documentation of the development of dams and So the white dots are dams that are either operational or in the works right now, and then the red ones are planned or proposed. And you can see that an awful lot of development has happened here. There's less development in the Congo, but I think the places where they have proposed dams, like putting one right at the very mouth down here, is not so good. And then comparing that to the species and the endemics within these basins, there's a lot of threat now. And unfortunately, the voices of people who have stakes in these fish and fisheries and ecosystems and ways of life apparently are not getting heard. We had quite a bit of a discussion about that at that session at AFS. So this is ongoing. Some writings have suggested that dam building is saturating, but I don't think so. It doesn't look like it to me. It's just moving. I think you all perhaps understand also from your discussions up here that we've lost a lot of the connectivity between, because of damming, we've lost a lot of connectivity between inland production and marine production. They've been greatly altered and diminished in general to the point where a lot of it's forgotten. In New York State, not many people remember what a shad is anymore, even though it was the country's most important fishery right up into the First World War, I think, outside of cod, which who remembers cod anyway, right? But these linkages have been written about quite a bit up here by scholars, and certainly by scholars in other places too. But we no longer have that great flush of shad and river herring and sturgeon and so on up into these rivers and producing fish that come out and then feed the coastal ecosystems. It's much diminished, but there's potential to come back. I'm giving a little shout out to the American eel, just because most people don't. Most people like to talk about river herring or salmon, things like that. But the American eel is also has taken a big hit from all of this, and we've felt the impacts in New York State quite a lot. So eels, just to refresh our memories about them, there are two species in the Atlantic Ocean. One is a European eel species, the other is an American eel species. They both spawn in the Sargasso Sea, and they ride the Gulf Stream. The European eels ride it over to Europe, and the American eel rides it to North and South America. And some of them stay their entire lives in marine waters, but a lot of them would settle up into inland waters and continental waters, grow, and then ultimately silver up and move back out to sea to reproduce, which has never been observed in the wild for these species. But they could penetrate. They penetrated all the way into the lower Great Lakes and up the up into Mississippi as far as Iowa and Minneapolis and so on. But very few are there now. Looking at dam development, you can almost do this for almost any region, I think, of this country, is to take a part of the country and split up dam development by 4 50-year periods, and you'll see kind of the same pattern. But this development in the Lake Ontario St. Lawrence Basin shows very much what happened to the eel. But the eels just got pretty much dammed out of habitat, and as a consequence, they're just about extirpated there. There have been some attempts to stock it back in, but it has produced some unusual results, I guess you could say. So that's happened, and now, for example, we live in the Iroquois, what's called the Haudenosaunee region of New York with the Iroquois Confederacy. The eel is the only clan that's a fish clan in the Haudenosaunee Confederacy, and many of the elders in the Haudenosaunee are eel clan, but most of them have not seen eels. So this is a problem, obviously. I'm just going to mention mining without going into it in great detail, but this is something that's probably more of a Western perspective. My colleague Bob Hughes is from the West, and we had a section in this talk before that was a long discussion about the impacts of mining. If you put out a map of mining, it's just like the dam one, pretty much, maybe a little bit more concentrated in some parts of the country, but we have again, the same kinds of impacts from mining as many of the other stressors. And this just happened, this particular one happened just before the Ecological Society of America meeting I went to, where a holding area was breached. So this kind of connotes that sooner or later, if you've got this kind of pollution stored somewhere, it's probably going to reach out at some point. And this is only these are only kind of the effects, the after effects, if you will. And this says nothing about what happens when we burn up that stuff either. But you do know that I think that the current administration is trying now to roll back some of the regulations on mountain topping in West Virginia. So this is a current issue for sure. So you guys may or may not know Alfred E. Neuman. He was a kid in a comic book series when I was a kid, Mad Magazine, but he comes up in my talk sometimes. So if we know that population and consumption have such impacts, why can't we talk about this? You know, why is it off the radar? That is my question. So this is a very famous diagram. This is, you should, Bridie went to the Resilience Alliance meeting in Stockholm recently, and this guy Johan Rockström wrote a very influential paper called Planetary Boundaries, and it describes all these different indices of sustainability that we should care about, and whether you should be, can we measure where we are in here. So if you're in the green zone, we're okay, it's sustainable. If you're in the red, it's not good. If you're off the charts like this, it's really not good. So that says biodiversity loss, not very good. But where's population growth? Well, it ain't in this thing. They very studiously avoided population discussion. It's radioactive. They put their hand on the third rail, and they didn't like it. So it turns out I stumbled across this paper. Somebody put it in front of me, i.e., that was an interesting paper about why journalists avoid this population and environment connection. And so they did a study and interviewed journalists about this. It says, you know, that Americans are less concerned now than they were 25 years ago. This was published in 1997. They're not connecting environmental degradation to population growth. And news coverage is a significant variable affecting public opinion, and how reporters frame a problem frequently signals that what is causing the problem. And so they did this study, and one of the takeaways is that they, interviewed 25 journalists whose stories on local environmental problems omitted the causal role of population growth. It shows that journalists are aware of the controversial nature of the population issue and prefer to avoid it if possible. Most interviewees said that a national phenomenon like population growth was beyond the scope of what they could write as local reporters. Maybe it's a scale issue. I don't know. But obviously studiously avoided. It seems like it's a taboo word, or these are taboo words in our dialogue. Overpopulation, immigration, ooh, that's a hot one. Birth control, which can be called family planning, and birth rate. These are just not popular words. And so I was asking, well, are only old folks interested in this topic now? And in fact, are junior scholars discouraged from taking up these issues? That's something we could ask. We could talk about it. And that there's been a kind of a 180-degree turnaround in what's permitted to talk about. So we can talk about toxicants still we're blue in the face, but can we talk about the fact that population pressure is making us pump out more of these products? It's hard. It's hard to do. Or can we talk about the fact that we know that there's a connection between indices of consumption like GDP and output of what we might consider environmental bads? We can see it, but we can't really talk about And so I asked this question: are we on a collision course with ourselves? I think it's a question that we probably ought to be asking. I mean, I don't know what the world is going to look like at 2050. I may not have to worry about it, but some of you will. We'll be about 9 billion people or so. And as I said before, most of humanity lives not so far from the coast, and it doesn't take a Miamian to convince you that there's some problems happening now. There's sea level rise, and increasingly with sea level rise combined with increased energetic activity of the atmosphere-ocean system, producing larger storms that are now, we're going to have some new categories soon, I think, of storm intensities, means that you're putting people in harm's way by having large coastal communities. So coastal urban centers, I think, are getting increasingly fragile because of these impacts. Put more people there, you're going to have more impact. As I said to Bridie before, I don't understand why coastal communities aren't negotiating to buy land inland, because why not? I mean, it seems like it would seem like a logical thing to do if you're in a flat area and you have the opportunity to move inland if you could. So it's something that I really am interested to see what is going to happen in the future. What kinds of new fields are going to arise. I said to Bridie yesterday, there'll probably be climate change law, climate change real estate, climate change or sea level rise, community coping. I don't know what's going to happen, but even here, I know in Maine you've got some problems already. So the point is, we need to talk, right? So I just took this. This was a cartoon with nothing in it, so I put in some text. So I think really that people need to bring up the issue, not be afraid of it. It's not a third rail, really, but we have to be able to talk about it. And so we have to learn how to manage value conflicts. And that is kind of one of the quintessential problems with sustainability, is getting through some of these humps. So this is a particularly sticky wicket, but it's one that I don't think we really should be ignoring. And that's pretty much all I have to say. I'm happy to attempt to answer questions.
I'll answer the first one then. I know you've thought about it deeply, but didn't quite mention it here. Could you speak a little bit about the dominant economic growth paradigm? How relates to all this? The assumption of neoclassical economics is that we have to grow the economy to provide welfare. And if you look at the flip side of that, that means you have to have people. You have to grow more people to support that growth. And if you actually look at all of the welfare programs that the world's countries have, they all also assume continual growth. So, is that what you want me to say? I want you to say what you want to say.
Well, that's what I want to say. I mean, they all feed on each other. I don't know how they can easily be decoupled at this point. A lot of economic or ecological economic theory is going into trying to think about how to do it, how to run a stable, sustainable economy without growth. And there are some good modeling studies of it, some books, and it is possible to do, but it takes a lot of careful planning. Yeah.
You talk about the harm in urbanization, but I was 11 years on school committee. We dealt a lot with town council. And what I found out, if people would live simply on farms in the places that weren't urban, that'd be nice. But what I found is that when people move into the areas outside the city, all of a sudden there's a great pressure to get all the same services that get in the city, and then there's the increasing of the commute between the jobs and the homes, more parking lots, more cars. So is this really, is there a
That's urbanization. So that's the process of it happening, what you're describing. And so remember that cities, Bangor was probably a crossroads once, but they've grown. So infrastructure grows. I think that although I said, I asked the question, how sustainable are cities? But really, that is where we're going to have to put ourselves, and we're going to have to make them much more ecological. I think they're going to have much more ecological functionality than many cities currently do. And there's some real promises. I mean, there's some really great work that's going on. Portland, Oregon, I don't know about Portland, Maine, but even little Syracuse, New York is trying to do some of these things. There are a lot of things that you can do to soften hydrographs, to increase the porosity of cities. So you can implement a lot of things with, you can hire a lot of environmental engineers and they can engineer a lot of nice ways of holding back water, and so that you don't have to overburden combined storm sewers, which are very common in the Northeast and so on. And questions about things like the people sprawling out, moving out of cities, that's, again, it's a community thing. I mean, communities have to talk about it, and zoning is, again, something that people are very allergic to, it seems. So you have to be able to get those conversations going, I think. And that doesn't mean, going out and having a cup of coffee necessarily. It means actually having meetings, I think, town meetings and stuff. I'm not sure what the local governance is like here, but in New York, we have something called home rule. So every town has its own say on what the land does, and they don't necessarily play in a regional context very well, but there are some mechanisms to try to help them do that. But no, I think ultimately we have to do that if we're going to really accommodate 11 billion people on this earth. So it's actually, in some ways, it's a really great opportunity for people who are thinking about how to make cities much more efficient. Maybe it's things like vertical agriculture. Maybe it's things like really clever ways of recycling water and making it the good things about cities are all the culture and those cultural amenities and things like that. That's what draws people to cities. But we have to handle our waste too in a sustainable way. So, I don't know, does that answer your question at all? What are you guys going to do in 2050? Yeah.
So Maine and the Penobscot are kind of good examples of some recovery.
Mm-hmm.
I'm afraid that the next step would be re-exploitation. Alewife are coming back in big populations, black seals and the whole fishery. If we improve runs, do you think that, how can you prevent the same thing happening again?
Ooh. Yeah, right. Make them watch old movies. I don't know.
Yeah.
I mean, it seems that there is cultural learning, but I don't know. I mean, it'd be more a question for Bridie or folks like that might know something about institutional learning and how it's preserved. But clearly, we've come some distance. We don't have outbreaks of the plague anymore on a regular basis and things like that. So there must be some learning that can be captured and instilled in cultures, I think. So I don't know. Maybe you can work on it. Yeah.
So what's your view of the demographic transition in all of this? There's probably some people who might not even know what I mean by that, and what do you think the data says about where we are? Some people seem pretty hopeful about where we might end up, population size, and I've heard other people that seem like they're pretty good demographers saying, don't get your hopes up. And I just wonder if you have a good sense of that.
I don't really get into the demographic literature, but what David is talking about is there's something called the demographic transition, which is kind of a phenomenological observation that populations tend to, the rate of population growth tends to decline after reaching perhaps an economic threshold, or education levels, things like that. But it's as I remember looking at the UN stats on it, it's a phenomenological model. has very little explanatory, very few explanatory drivers in it. So I think it makes sense, but I don't know how, I think the demographers, if they're telling you that it doesn't work all the time, I'm sure they're right about that. But certainly, I mean, many countries are, dropping birth rates. I mean, with the U.S., I believe, I haven't looked at the stats in a couple of years, but I think that if it weren't for immigration, we would be losing population by, I think around 2027, we're going to be at a crossing point where if we didn't have immigration, we would be losing population. So, and some countries already are losing population. The question is, though, is that a bad thing? I mean, a lot of countries are very worried about it because of the reasons we just discussed, that fewer people means less economic growth, and that's anathema in the current worldview. So, yeah.
I know one thing about population is in the third world countries where they have a lot of population rise, that the biggest key that they can do to controlling population is educating the women, because when women are educated and they're in control of their own, how many children they're going to have, and they're able to provide nutrition for their families, they're not having like 10 kids so that a few will survive, they're having fewer kids. And so it seems to me that, we're doing the wrong thing because we're trying to keep them from having access to birth control, and that we should be expanding the access to education and expanding the access to birth control.
Why aren't you running the country?